The quickest way to find a confidence interval estimate for the population mean will be Stapplet. In Stapplet, we first need to identify what kind of variable we have. We're either going to use a categorical variable for population proportion, or we'll use quantitative variable for population mean. In this case, we want to estimate the population mean. One of the giveaways here is going to be if we're given qualitative or quantitative statistics. In this case, a mean and standard deviation, those are quantitative statistics. We do not have raw data on this problem. Later, I will show you a problem with raw data. Here we have a mean and standard deviation that we need to enter. From my given information, I see that the mean is 38, the standard deviation is 5, and there's 14 people. So that is my mean, standard deviation, and n. And the variable here is the amount spent on a gift. And then we begin analysis. We don't see all of the statistics that we would when we put in raw data. Here the only option is going to be perform inference. This chapter we are doing a one sample t interval. Next chapter we will do a one sample t test. The only other thing we need to know is the confidence level. That will either be given or we will pick. In this case, we need to use the one that's given of 95%. And that is already there. Perform inference gives us our lower bound, upper bound, and df stands for degrees of freedom, which is n minus 1 for one variable. From the lower and upper bound, we can either report our trilinear inequality for the confidence interval, or if we need to find the margin of error, we would need to subtract and divide by 2. We already do know the point estimate, so the confidence interval would be 38 plus or minus a margin of error, and to find that, I'm going to go to the Desmos Scientific Calculator. And like we did before, that's 1/2 of the high minus the low. And I'll just go ahead and use the full precision and wait to round until I'm done. So on this problem, the margin of error is about 2.9, and it's asking for 2 decimal places, so that would be 2.89 for the margin of error. Here is another version of the problem where we have raw data. When we have raw data, we're going to go all the way back to stapplet.com, starting with one quantitative variable single group, and here it's already set to raw data. So this one, we have the period of effectiveness in hours. If you want to just put hours or even leave it blank, that is okay. And then I'll copy the data and paste those in and begin analysis. Now I'm going to have some additional information, including summary statistics. This sample mean there is my point estimate. To find the margin of error or the full confidence interval, I need to go to inference and one sample t interval. A lot more options this time because I did raw data. Going back to the problem, I'm going to scroll down and see that this is a 95% confidence interval. There's a lot more going on, but we can answer all those questions. For now, let's just get that lower and upper bound. Now looking back at the problem, first the point estimate, like I said, was sample mean. That's 2.425. And I don't have quite the 4 decimal places, so I'm going to go over here and just double check. And it looks like at least my numbers go out to 6 decimal places. So that is as accurate as I can get with Stapplet. We will always use a t-distribution for these, and that's a newer distribution. It's going to account for the uncertainty of estimating the mean because our sample is also estimating the standard deviation at the same time. And to be able to do this, we need to either have a normal population or a large enough sample size. And so that will be that third option. Here, they give us the margin of error. We also have calculated it here. Now, the only thing I would maybe do is double check, is 2.425 plus and minus this number going to give me the same thing? And that would be 2.68 and 2.17. So that looks good for that answer. And in this type of problem, we are using interval notation. So that's parentheses and then low to high, like so. To be 95% confident, that means if we were to repeat this, we would get it right 95% of the time. Or in this population, if we were to continue sampling, 95% of those samples will give us an accurate confidence interval, or confidence interval containing the mean. And they could have a mean of 2 hours. Because of sampling error, we only have 95% confidence, not 100% confidence. Is it likely? It is not likely. It is possible, not likely. So there are all those correct answers.